This is the fourth video of our IR lecture series. In this video, we will examine 3 IR spectra and start practicing looking for main functional groups and matching structures. Our first IR spectra, we can see in this spectra, we're looking at an alkyne and an alcohol. In the alkyne, if we remember, the main peak for the carbon-carbon sp triple bond tends to show up around 2000. And we can see here, we have a sharp peak around 2000, which indicates we have a triple bond. We can also see here that around 3300, we have a strong spike. This is indicative of the carbon-hydrogen for our terminal alkyne. We can also see in this region, we have a very large broad peak, which is indicative of our alcohol group. So that would be the OH for your alcohol. As you can see, it's a very large broad peak, comes down in kind of a U shape. The only reason that U shape is interrupted is because of the carbon-hydrogen triple bond. We can also see here we have more carbon-hydrogen peaks for an sp3 hybridized carbon. You can also see the carbon-oxygen single bond, which shows up around 1000. As you can see, it's a strong peak. It's a slightly broader peak than most of the carbon-carbon single bonds. And if we look at all these peaks together, we can see we have all the major types of bonds within our structure shown. So this means we have to have that triple bond, and we also have to have the alcohol. So let's look at our second example. In our second example, we have an alkene. And if we remember, the carbon-carbon double bond tends to show up around 1600. And we can see right here, we have a carbon-carbon that's sp2 hybridized. It's right around 1650 where our double bond tends to show up. We also have carbon hydrogens from an sp3 hybridized carbon. When we look at these peaks, they tend to kind of come down as a clump with multiple spikes at the bottom. It's easiest to group them all together and just say carbon-hydrogen sp3 hybridized. You can also see we have another peak here. This peak, as you see, is right above 3000. That means it's our carbon-hydrogen double bond peaks, or carbon-hydrogen sp2 hybridized peaks. And once we look at all these together, we see we don't have any other major functional groups present. So this means the only functional group of interest present in the molecule would be that carbon-carbon double bond. And so now looking at our third structure. Our third spectra involves a ketone and an aromatic ring. So as you can see, the ketone, the carbon-oxygen double bond, shows up right around 1700. We can see it's a very strong peak in our spectra. One important thing when we're looking at our IR spectra is always look for your strong peaks. Look for the peaks that stand out. Don't worry about all these other little peaks. We can also see right around 1500, we have our carbon-carbon double bond. So you can see the difference between the carbon-oxygen double bond and the carbon-carbon double bond. We also have other bending for our aromatic ring right here around 1500. But you can see your carbon-oxygen double bond is always going to be much stronger than your carbon-carbon double bond. If we look at the carbon-hydrogen region, we can also see here we have our carbon hydrogens for an sp3 hybridized carbon. And then we also have multiple peaks for a carbon hydrogen that's sp2 hybridized. One thing to notice in this spectra is notice we have aromatic overtones. You can see we have all those bumps right here between 1800 and about 2000. Remember, when you see these peaks, you know it has to be an aromatic sp2 hybridized carbon versus a alkene. But as you can see also in the fingerprint region, we do not have any carbon-oxygen single bonds, and most of those peaks there are your carbon-carbon single bonds. Those we do not need to worry about. But so you can see from these three examples, we are looking for only particular peaks associated with those functional groups. We only need to look for the main peaks. We do not need to spend our time looking through all of the spectra. In our next video, we'll examine a few more spectra, but without the structure drawn. So we'll have to figure out what the functional groups are based on the spectra alone.